Hello friends, today I will discuss about current transformer saturation and impact of CT saturation on protection system. Before going through this video, you are requested to please go through my channel and do subscribe my channel if not subscribed earlier, and press bell button for notification of videos to be uploaded in future. So what does the current transformer do? The basic principle or basic function of the current transformer is to carry the primary current. Due to flow of the primary current, a flux will generate in the core, and due to this generation of the flux, very low amount of current will induced due to magnetically coupled of the CT. So current transformer has much number of turn in the secondary circuit, but in the primary circuit there is a single turn or no turn at all in the primary circuit. So there are two types of current transformer. One is the metering CT, which is used to measuring purpose, and another is protection CT, that is used for protection purpose when the CT secondary input is connected to the relay. This relay will sense the current magnitude depending upon the fault condition and decide whether it is a faulty condition or not based on the setting given to it, and it will send a trip signal to the circuit breaker to isolate the faulty system. So our main concern is the CT saturation and impact of CT saturation in case of protection system. So there are two types of protection CT. One is the protection class CT and another is protection special class. In case of protection CT, it is defined by 5P10 or 5P20. That is, if 10 or 20 times of rated current flows in the primary side, then the error in the secondary side shall be 5% or 5% respectively in the secondary circuit. Again, another class of CT is protection special class. It is defined by the knee point voltage or VK. That is, it can measure the higher ranges of primary current, and it is normally nowadays a wide range of used in protection class protection purpose. So what is the definition of the knee point voltage? Knee point voltage is the voltage at which at 10% increase in secondary voltage of CT secondary result in 50% increase in the secondary current. This is the definition of the knee point voltage. Now how the knee point voltage test is done? In order to carry out the knee point voltage test, we have to first go through the nameplate details of the CT. Here a CT has been shown which has three number of cores. Normally first core is the metering core and the other two core are the protection core. We have to see what is the value of the knee point voltage in the nameplate for protection CT. Normally knee point voltage test is done for protection CT. So here second and third core are the PS class CT, and knee point voltage test will be done on second and third core. That is, knee point voltage for 2S1 and 2S2 is different, and again 2S1 or 2S3 is different, and it shall be the value of the knee point voltage for 2S1, 2S2 and 3S1 and 3S2 shall be same. Again for 2S1, 2S3 and 3S1, 3S3 shall be same. So for carry out the knee point voltage test, we have to disconnect all the secondary circuit, that is cable connected from the 2S1 and 2S3 shall be disconnected first, and we have to inject variable voltage supply, gradually increase this voltage up to knee point voltage. When this knee point voltage comes, and 10% voltage will increase, which will result in 50% increase of the excitation current. Then this voltage will be satisfied. In this test, we must ensure that the result which get at knee point voltage, which shall be at par with the nameplate mentioned knee point voltage or above knee point voltage. So the test procedure for knee point voltage calculation of the CT. First we have to disconnect the CT from all external connection, both from primary and secondary circuit, and note down the knee point voltage which is mentioned in the nameplate of the CT. And first we have to apply the 5 to 10% of the voltage of the knee point voltage at mentioned in the nameplate to the secondary of the CT. First we have to measure for 2S1, 2S2, then 2S1, 2S3, if we, and again for third number core. So by means of the auto transformer, note down the secondary current, increase this voltage gradually to 20, 30, 40 and etc. up to 90% of the rated knee point voltage, and we have to note down the secondary current. Now increase the voltage at 100% of the knee point voltage and note down the current. Now if we increase this knee point voltage further 10%, then observe the increase of the secondary current. If the secondary current increase 50% with the increase of this 10% voltage, then the knee point voltage of the CT is the voltage as mentioned in the serial number 5 in this picture. So this is how the knee point voltage test is done. So importance of knee point voltage for protection system. First we will discuss about importance of knee point voltage for restricted earth fault relay. So restricted earth fault relay for star side star winding of the transformer has been shown in this figure. We already knows the connection for the restricted earth fault relay, that is P1 shall be connected towards the bus side and P2 shall be connected for the transformer side for all phase CT, and for NCT P1 shall be connected towards the earth side and P2 shall be connected neutral point of the transformer. So all the S1 terminal of the secondary circuit of phase and neutral CT is connected together, and all the S2 terminal are connected together to feed up the restricted earth fault relay shown in this diagram. So the knee point voltage for all the phase CT and the neutral CT shall be same for REF relay. Now consider the knee point voltage of either any of the phase CT or neutral CT is not equal. Now consider earth fault occur in the red phase to neutral outside the zone of the restricted zone. Due to this fault, as the knee point voltage of the NCT, consider the NCT knee point voltage is not same with that of the phase CT. So due to different knee point voltage for NCT, the NCT will saturate first. So due to this, there will be a mismatch of current in the secondary circuit, and which lead to the maloperation of the relay. In order to avoid this maloperation of the relay, a stabilizing resistance is used in series with the relay. Now impedance of the knee point voltage or VK for differential relay. The differential relay connection for YND1 type transformer has been shown in this diagram. Here the relay is MICOM 642. Connection for HV side and LV side has been shown. Under any through fault condition, either in HV side or LV side, if any of the CT, that is either HV side or LV side CT saturate, in order to prevent the relay to maloperate, bias characteristics is given to the relay. Now again the importance of the knee point voltage for busbar protection relay. The busbar protection relay connection has been shown in this diagram for 3 number of feeders, where 2 number of feeders is feeder 1 or feeder 2 are the incomer and feeder 3 is the outgoing feeder. So the knee point voltage for all of the CTs shall be same. If knee point voltage all of the 3 feeder CTs are not same, then under through fault condition, then CT saturation may occur. In order to prevent maloperation of the busbar protection relay under through fault condition due to variation of the knee point voltage of any of the CT, a stabilizing resistance is connected in series with the busbar protection relay for high impedance differential protection. Again, for low impedance type differential protection, bias characteristics is given to prevent maloperation due to CT saturation.